In this video, we'll see how the enthalpy and entropy of reaction affect the Gibbs energy. In fact, let's start with a definition. So the Gibbs energy change for a reaction is delta H minus T delta S. And that's one of those top 10 equations in chemistry you should probably take with you to your grave, I would say. All right, what is the criteria for spontaneity? Well, if delta G is less than 0, it is spontaneous. If it is equal to 0, it's at equilibrium. And if it's greater than 0 or positive, it is non-spontaneous, which means two things. So one, it means it's spontaneous going backwards, and two, it means, kick in some energy, and we can see about making this go. So let's have a look at how delta G is affected by delta H and delta S. In fact, let's draw up a table, and there's delta H, there's delta S, and we can talk about what happens to delta G as we look at those four possible combinations. So for instance, if delta H is always negative and delta S is always positive. So look what happens to this equation here. If this is negative, that's very favorable. If this is positive, we flip the signs and we make this negative. We got two negative numbers. That makes the whole thing negative, which means it will always be spontaneous. So we will find that reactions that are exothermic, right, have delta H's that are negative, and increase in entropy will always happen. So they're always spontaneous. There's no temperature at which we can turn this off. Conversely, if we look at reactions that are endothermic, that decrease the entropy of the reaction, we will see the exact opposite thing. If this is positive, that's unfavorable. If this is negative, that looks good, but we flip the sign, we make it positive. Two positive things add up to a positive thing. Delta G can never be negative. It can never be spontaneous. So it's always non-spontaneous. So without putting in energy, we can never get these reactions to take place. What is interesting is that there's another combination here. So for instance, if delta H is positive and delta S is positive, then we get two competing effects. So this is positive. Imagine you make the temperature 0, then this term would go away. So delta H would be positive, delta G would be positive at low temperatures. So if it's positive, what does that mean? Yeah, it means it doesn't happen. So it's non-spontaneous at low T. And when T is really large, then this term here dominates. So you've got minus a very large number times a positive number. So that is minus a very large number here. And if this is positive and this is negative, as the temperature increases, this becomes more and more negative, can overwhelm this and turn the whole thing to be negative, which means it is spontaneous. So it'll be spontaneous at high temperature. And the other way, actually, also holds. So if delta H is negative and delta S is negative, then we get something kind of interesting, because at low temperature, delta H is the important term. It's negative, which tells you that it is spontaneous at low temperatures. Okay, in the limit that T goes to 0, right, only the delta H term survives. When temperatures get larger and larger and larger, this becomes the dominating term. You've got a negative times a negative, so that's a positive. And remember, for delta G, right, a positive delta G is non-spontaneous, so it becomes non-spontaneous at high temperature. So you see this opposite effect here. So this will always go, this will never go. And this will go at high temperature, but not low. And this will go at low temperature and not high.